Hello, my name is Hector Rivero, and welcome to my CS50's Introduction to Programming with Python final project presentation. The project is titled Bookkeeping Assistant. My GitHub username is admin Rivero, and my EDX username is Hector Rivero altogether. I'm based in Toronto, Canada, and today's date is November 9th, 2025. Let me show you how this project works and how it helps automate small business bookkeeping. Bookkeeping can be tedious and error-prone when done manually. Small businesses often export transactions from banks or credit cards into CSV files, but these files vary in format and require hours of manual classification. My project solves this problem by ingesting these CSV files, applying rule-based classification, and exporting a clean, formatted Excel workbook ready for accounting. So here we are with the project code base. Let's quickly try to explain how it works. Like I said, this is a modular design and rules driven. So the first thing we'll do is to ingest this CSV file, which is your bank account transactions, raw transactions, that you will place under data and the tax year. Let's take a look at this raw transactions file. This is small sample size of 50 transactions. The program will normalize the format and it will iterate over each of these transactions, applying the rules. This is another small sample size of the rules, but it's useful to illustrate the dictionary and the keywords that you might be using to put together these rules. Here you have rules to classify different type of business expenses. For example, here at the end I have a very particular rule that flag for manual review ambiguous transactions. So let's take a quick look at the program running. Let's open the terminal. Here, as you can see, I'm using a virtual environment for the Python dependencies. Let's call Python. I'm on Windows, so it's the short version project.py, and let's pass it the tax year. In my case, it's 2024. Let's hit enter, and this is the output. Sorry, let's open this terminal. As you can see, it's telling us how it went on each step. First, it loads the rules, build the exporter, which is the module in charge of creating the spreadsheet, and then it will start classification and mapping the transactions. Once it classifies them, it will map them into the resulting spreadsheet in each column. And yeah, it says total roles complete and success pipeline completed. So here under output and the target tax year, which is 2024, it will place the spreadsheet. So right here. Okay, so since I don't have any extension to view the Excel here, I will have to go to the Windows and using the Microsoft Office. So here we have the resultant spreadsheet with the desired format and a mix of classified and unclassified transactions. Those highlighted in yellow are telling us that the system flagged them for manual review, as you can see it here in this notes column. And all the technical knowledge and data related to this spreadsheet, I will save that inside the docs folder as well. Okay, let's cover our options when we run the program. Like I said, this is a simple but flexible interface where we can call our program by passing the tax year, which in my case is 2024, and we can also indicate if we have a different rules file using the option rules, and then the path to the file config. This is relative to the project root, allocation rules, sorry, .json. And let's do something different this time. Let's, instead of printing all the steps. Let's run it in quiet mode this time. Just gonna use the options. Rules error. Rules file is not found. Okay, that's a new extension that I just created. JSON. Okay, and there we have it. We're only gonna have the final message telling us if it was successful or not. Okay, so let's try a different one. We can also, instead of using the prints, we can use the login, indicating the pattern or the option log. So we have now more information, the date, the time, and the type of message, useful for debugging. We can, instead of having this output in our terminal, we can set up a different handler here to use, for example, a file, so we can store this output inside a file. Okay. This version 1 successfully meets all CS50 programming with Python final projects requirement with a modular design, testing, and a professional workflow. Looking ahead, the next evolution could involve machine learning. Instead of defining rules manually, a dedicated machine learning module could analyze historical classifications to generate and refine rules automatically, making the system truly self-learning. Also, for the next version, the enhancements will include PDF ingestion for receipt processing, fuzzy matching to handle minor description variations, and implementing continuous integration for deployment. Thank you for watching my presentation of Bookkeeping Assistant. I hope you enjoy seeing how Python and automation can transform tedious, error-prone bookkeeping into a streamlined, high-value process.